We're looking at the antiderivative word problems worksheet. Number one, the rate at which people enter an amusement park is given by the function e, defined by e of t. So this is the rate at which people are entering into the park, people entering per hour into the park. The rate at which people are leaving this same amusement park is given by L. L of t is given by this equation or this function here. This is the rate at which people are leaving per hour. So both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. So the functions are valid for 9 to 23, so 9 a.m. to 11 p.m., the hours during which park is open. Okay, t equals 9, represents 9 a.m. So part A, how many people have entered the park by 5 o'clock? So people entering the park, we know this is going to be related to E of t, okay? But it's not as simple as plugging 17 into E of t, because E of t represents the rate at which people are entering into the park. So if we want to find out how many people have entered in the park, who've entered the park since the beginning of the day at 9 a.m., then what we need to do is we need to accumulate this rate over the course of the 8-hour period. Okay, so what we need to do then is we have to involve definite integral. Okay, so E of t is the rate at which people are entering the park. So if we want to find out the total number of people who've entered the park, then we have to accumulate that rate. The way we accumulate rate is we use definite integral. So if we take the definite integral of that rate from 9 to 17, from 9 a.m. to 5 p.m., then this will give us a total number of people. So if we plug this in our calculator, work this through, it'll give us 6,004. So roughly 6,004 people have entered in through the gates of the park. All right, part B, the price of admission is $15 until 5 p.m. After 5 p.m., the price drops down to $11. So how much money is collected from admissions on that given day? So what we can do is we can find out the total number of people who've entered in the park, which we did from part A. We can also we're going to find a total number of people who've entered the park from 9 to 5 p.m. and then find the total number of people who've entered in the park between 5 p.m. and closing time. And then after we find out these numbers of people, then we can multiply them by however much they'll be charged depending on what time they're coming in. So here, this is 6,004. We found that from part A. So we take this number of people who've entered in the park before 5 p.m. and each of them gets charged $15. So 15 times 6,004. So this will give us the revenue for a number of people up from 9 to 5 p.m. And then the integral of 17 to 23, we need to use our calculator to find that number. And then we take that number of people and we multiply it by 11 because everybody who's entering the park after 5 p.m. will only be charged $11. And then we we add the total between those two revenue amounts, and we're going to get $104,048. Okay. Part C, let h of t equal to the definite integral from 9 to t of e of x minus L of x. The value of h of 17 to the nearest whole number is 3725. Find the value of h prime of 17 and explain the meaning of h17 and h prime of 17. So h of t is a definite integral from 9 to t of e of x minus L of x. So what we're doing here is we're accumulating the number of people who've entered in the park, and then we're also accumulating the number of people who've left the park, and we're subtracting those. Okay. And then from 9 to t would indicate t would represent any has the flexibility to adjust to any time that we want to find out. Okay, so what this is going to do is if we find h of 17, then it's the integral from 9 to 17. So from 9 to 5 p.m., if we accumulate the number of people who entered in the park and then we subtract the number of people who've left the park, then this will tell us exactly how many people remain inside the park at 5 p.m. Right, so if we plug this in our calculator, we'll get 3725. Number of people who are in the park at 5 p.m. All right, so we know h of 17 or h of t represents the number of people in the park at any given time. But h prime of t will represent something a little different, right? Because now if we find an h prime of t, now this will tell us the rate at which people is entering or leaving the park at that moment in time. And if we find h prime of t, which we need to do before we find h prime of 17, so h prime of t just means that we want to find the derivative of this integral. So when we pair up derivative and integral next to each other, they're going to essentially cancel out. Using second theorem of calculus, we just have to plug in the upper and lower bound. So e of t minus l of t. So h prime will represent the rate at which the number of people is entering or leaving the park. So e of t minus l of t. So if we want to find h prime of 17, then it'll be e of 17 minus l of 17, which is ends up being negative 380.281. So this tells us that at 5 p.m., there are more people leaving the park than entering the park at the rate of 380 people per hour. Okay, and this should make sense. This should be a reasonable thing to that should make sense, just because at 5 p.m., closer to the end of the day, we expect more people to be leaving the park than entering in the park. Okay, part D. At what time does the model predict that the number of people in the park is at a maximum? The number of people will be at a maximum when the rate is equal to 0. So when the rate is equal to 0, that just tells us that is when the rate at which people are entering the park matches the number of people who are leaving the park. So it's going to be after this particular moment in time, then the rate at which people are leaving the park will start increasing, and the rate will start to decrease. So the maximum rate will occur when this h prime is equal to 0. Okay, so here, the number of people in the park will keep growing until the rate at which people are leaving grows to be higher than e of t. So right before L of t beats out e of t, that will be when the maximum number of people, and we expect that number logically maybe to be sometime in the mid-afternoon, right? Early to mid-afternoon is maybe when the maximum number of people will be inside the park, and then after that moment in time, then more people will start to leave the park. So ends up being 15.79, which is going to be about 3 p.m. Okay, all right, let's look at number 2. This is number 2 on the back here. This is on problem on traffic flow. Traffic flow is defined by which the rate at which cars pass through an intersection. So the traffic flow at a particular intersection is given by f of t is 82 plus 4 sine of t over 2. Now notice that f of t does not represent the number of cars. It's the rate, the traffic flow at that moment in time. So then part A says, to the nearest whole number, how many cars pass through the intersection over the 30-minute period. So if we know f of t is the rate at which cars are crossing the intersection, then if we accumulate that rate over the given amount of time, then we're going to be able to come across the total number of cars. So the depth integral from 0 to 30 of this traffic flow will give us a total number of cars. Because remember, traffic flow is cars per minute, not the total number of cars. So if we plug 30 directly into f of t, we're not going to get the total number of cars. We're going to get the rate at which traffic flow is increasing or decreasing at that moment in time. Part B is the traffic flow increasing or decreasing. So at t equals 7. So then we can just plug traffic flow is f of t. So if we want to find out the rate of change of traffic flow, is it increasing or decreasing, then that involves us to find the f prime, the rate of change of traffic flow. So we need to evaluate f prime of 7. So f prime of 7 just means that we can use our calculator. Under Math 8, you can do AntiDerivative and then plug in the traffic flow equation from the given here. and then comma x comma 7. So this will plug 7 into the derivative of f of t, and we're going to get negative 1.872. So that tells us that since this value is negative, traffic flow is going to be decreasing at t equals 7. Part C, what's the average value of the traffic flow? So average value theorem, we can use the 1 over b minus a, definite integral from a to b of f of t. So let's just find the average value of traffic flow. A is 0, A is 10, and b is 15. So we just plug this into our formula. So 1 over 15 minus 10, definite integral from 10 to 15 of f of t, and we get 81.899 cars per minute. Part D, what is the average rate of change of the traffic flow? So average rate of change is just going to be the change in traffic flow over the change in time. So it's just basically using the slope formula. So change in traffic flow is just f of 15 minus f of 10 divided by the change in time, which is 15 minus 10. And again, we use our calculators. We find f of 15, we find f of 10. We subtract those values and we divide it by 5. And we get 1.517 cars per minute squared. This is because traffic flow is already cars per minute. Rate of change of traffic flow will be cars per minute, which is therefore cars per minute squared.